Hello class, hope you're doing well. Our next section in math, section 9.3, is on the Pythagorean theorem. So I'm not sure how much you know about the Pythagorean theorem. This might be old school for a lot of you guys, but it's called the Pythagorean theorem because there was a fellow Greek mathematician named Pythagoras, and he is the mathematician who developed this. And basically the Pythagorean theorem is this: a squared plus b squared is equal to c squared. So what do the A, B, and C stand for? Well, we're talking about right triangles. We're doing a little bit of geometry. Every right triangle, of course, every triangle has three sides to it. The two sides that make up the right angle are called the legs. So every right triangle has two legs, and we designate those legs with the letters A and B, and it doesn't matter which one's which. They're interchangeable. The side that is opposite the right angle, we always designate with the letter C. It's called the hypotenuse. And the word hypotenuse is a funny word, right? Hypo like hypodermic needles, or hypoglycemia, which is low blood sugar, or hypothermia, which happens when someone gets too cold. Hypo means under. And I looked this up. This tenuse means to stretch. The way that the Greeks used to draw right triangles was always with the hypotenuse on the bottom. So it's under and it's to stretch. So your little trivia for the day, that's where the word hypotenuse comes from. The hypotenuse is always the longest side. Always the longest side, the hypotenuse. Okay, so we have this wonderful relationship about the length of the legs and the length of the hypotenuse, and that's the Pythagorean theorem. The length of a squared plus b squared will equal to c squared. And I'm sure that you have seen drawings. There's some in your book. A squared is actually the area of the square on A, and b squared is the area of the square on B. And if you added those two areas together, it would equal the area of the square on C. And I think there's something like 120 different proofs of this, because theorems you'll learn in geometry can always be proved. And people like presidents and other people have developed proofs to the Pythagorean theorem. All right, that's enough historical document. Let's get into the math. So here we go. We have a right triangle. Should have our little square there. What is the length of this side? Well, these two sides make up the right angle, so we can call one A and we can call the other one B, and then this would be our hypotenuse C. And then we simply write this out. A squared would be 212 squared plus b squared, 478 squared, and this will equal to c squared. Just realized I forgot my calculator. Just a minute. Okay, so here we go. We need to square 212. I'll just show you how I'm doing it. 212, see this x squared button? Add it to 478 squared. Hit the equal to sign. And so this is what c squared is equal to. So the way that I'm going to solve this equation is I'm going to square root both sides. So let me just write this in here. C squared is equal to 273,428. 273,428. So in order to find C, I need to square root both sides. So I'm going to square root C squared, which you know now is C, And then what is the square root of this number? Well, the way that I'm going to do that, I'm going to hit the second key, second square root. And then instead of typing that whole number in, I'm going to suggest that you get familiar with this. ANS stands for answer. See how it's up on the top? So we do second, that pops in, that long number, and then equal, and we have 522.9. Now you might ask, are we using decimals, or are we going to simplify them the way that we learned how a lesson or two ago? For a number as large as this, man, oh man, I don't want to simplify that. So let's just put this down. So C is approximately equal to 522.9. Okay, that's how long that would, the hypotenuse would be. Alrighty, now here's the second type of problem. We have a right triangle again. And note that the two legs, one leg is given. If this is called A, we better call that guy B. And we know the hypotenuse, which is C. So we're going to have to do an extra step in here to solve for A. But first, let's go ahead and use the Pythagorean theorem. A squared is unknown, plus B squared, B is 10, is equal to C squared, which is 12. All right, now using the order of operations, we have to find out what these numbers are before we go subtracting off. So A squared plus 10 squared is 100, and 12 squared is 144. How do you solve for A? Now we're going to subtract 100. And we would get, let me move it over here, A squared is equal to 44. All right, so I could use my calculator to find the square root of 44, but just for fun, let's do a little review here on solving this exactly. Remember, when we use our calculator, we take the square root of a number that's not a perfect square. We have an approximation. Those two squiggles means approximately equal to. C is about 522.9, I should have labeled this feet, right? This is an irrational number. But over here, let's just write this as an exact number. So if you remember 44, what's a perfect square factor of 44? That's 4. 4 times 11 is 44. And we can take the square root of 4, which is 2. 11 is a prime number, which means it can't be broken down anymore. And anyways, we know exactly A, the length of this leg, is 2 times the square root of 11. Don't be worried about which way should you do it. The book or I will indicate find the answer in simplest form or find an approximation. And remember, whenever you have a word problem, then we can always find an approximation. All right, I wanted to take a look at number 6 in your book. So if you want to turn to page 491, number 6, this is a classic problem that you will see over and over again in math. The ladder against the house. All right, why the ladder against a house? Here's your house, and here's the ground. Okay, here's our grass. The house and the ground always form a right triangle. So number 6 says a ladder is 15 feet long. Here's your ladder. And we know that, is that a leg or the hypotenuse? This is the hypotenuse, C, correct? The house is a leg, and the distance, the bottom of the ladder is 5 feet from the wall or the side of the house. So this is 5. And we want to know to the nearest foot, how far up the wall does the ladder reach? So we're trying to find, what is this height here? We're trying to find A. And notice it said how to the nearest foot. So we're going to round off here. We're going to round off. Right, here's my B. So let's go ahead and write out the Pythagorean theorem. A squared plus B squared is equal to C squared. Okay, remember that we can't just subtract off that 5 squared from 15 squared and get 10 squared. Don't be doing anything crazy like that. We first have to evaluate the values. So 5 squared is 25 and 15 squared is 225. Subtract the 25 from both and we get A squared is equal to 200. This is a real world problem and they said to approximate. So we're just going to grab our beautiful calculadora and we're going to take the square root of 200, which is about, if you can see that, 14.142. So rounded to the nearest whole number, this would be approximately 14 feet tall. 14 feet on the house. All right, one last little bit here, and this is example 3 in your book, I believe. Example 3. The question is, do the following side lengths of a triangle form a right triangle? Well, the Pythagorean theorem says in a right triangle, a squared plus b squared equals c squared. So if this works, then yes, your triangle is a right triangle. If this is not true, then you would say, no, it's not a right triangle. So we're asking ourselves, does a squared plus b squared equal c squared? And remember, even though they're not given, c is always the largest number. So here, c would be 7. So we can just say a and b. And then now we're just going to write it out and see, is it equal? So is 3 squared plus 5 squared, is it, so I'm going to put a question mark, is it equal to 7 squared? Now we get to do the math. 3 squared is 9. 5 squared is 25. Is that equal to 49? I don't think so. This looks like it's 34, which is not equal to 49. So we would say no, not a right triangle. Okay, and they gave us 2, so probably this one is going to work. Here's our C. Let's just do it real quick. Is 8 squared plus 15 squared equal to 17 squared? Question mark. 8 squared is 64. 15 squared is 225. 17 squared, I think that's 389, but I better check. 17 squared, 289. Is this equal to 289? And when we add 64 and 25, we do in fact get 289 is equal to 289. Check. So we would say yes, this is a right triangle. Okay, this brings to mind something that I want to mention because you are mathematicians and this is something that will become important to you. There's such a thing as Pythagorean triples. I'll just mention it now. Some of you may have heard of them. Pythagorean triples are whole numbers that satisfy the Pythagorean theorem, whole numbers. So the Pythagorean theorem, that's an abbreviation for theorem, TH with a little M up there. So down here, we had whole numbers 8, 15, and 17. That's a Pythagorean triple. And I would challenge you to try and find 3 numbers that also are Pythagorean triples. I was going to give it to you, but I think it might be more fun if you find them yourself. All right, speaking of fun, I hope you're having fun at home doing your math. I will post this on the classroom. This will be due on Monday, the first assignment of quarter 4. Take care, y'all.